Today we're going to discuss balancing equations. Just as having a bunch of kids on a seesaw, you have to make sure they're balanced or else, well, we don't get to have as much fun. That's how chemistry is. If our reactions are not balanced, well, we don't get to have as much fun. Alright, so what's this from? Monty Python. So in the movie, this woman was accused of turning somebody into a newt. And so their logic went, if she weighs more than a duck, then what was she? She was a witch, burner. Okay? So their logic wasn't necessarily the best. I hope ours can be. So the idea here is if you have two different things on both sides of the equation, how do we figure out how to make the scales balance, how to make them so that their weights are equivalent. That's what we're going to be doing in today's lecture, is balancing equations. So to begin with, what needs to be balanced? The reactants need to balance with the products. So just kind of as a reminder, reactants are on the left side of the arrow, products are on the right side. If you have a little g, that means gas. Little L, that means a liquid, little s is solid, and little aq is aqueous, which just means it's dissolved in water. Alright, so learning how to write and how to read chemical equations is a lot like learning how to read English. So for instance, the charcoal used in a grill is basically carbon. The carbon reacts with oxygen to yield carbon dioxide. The chemical equation for this reaction is carbon plus O2, which is diatomic oxygen, to yield is the arrow carbon dioxide. It contains the same information as the sentence I just read in English, but it also is quantitative, and we'll discuss what that means here in a minute. So kind of the idea here is on the left side, you should say, for instance, carbon reacts with oxygen, and if you say oxygen or if you say nitrogen, you're assuming it's diatomic if it's room temperature, and that's because of those 7 atoms that are diatomic. You got your hydrogen, your oxygen, etc. To yield, so the arrow is the to yield part, and then carbon dioxide is the product. If there were 2 products, it would be to yield carbon dioxide and then you would name whatever the second one is. So this is kind of a little bit of practice of using our how to say chemical formulas with a little bit of just reiterating the to yield and reacts with part of an equation. So how do we balance an equation? So what matters the most is that the number of atoms on both sides of the equation need to be the same. So meaning, if we have 2 hydrogen atoms on the left, we need to have 2 hydrogen atoms on the right. If we have 2 oxygen atoms on the left, we need to have that many on the right. So in answering this question, how many oxygen atoms are on the left? 2. How many oxygen atoms are on the right? 1, 2, 3. There are 3. And they're depicted in red for you on the screen. How many hydrogen atoms are on the left? 2. How many hydrogens are on the right? 2. So is this equation balanced? No. Why not? Because we've got 2 oxygen atoms on the left and 3 on the right. So balancing equation is simply figuring out how to make it so everything balances. You have the same number and type. That's the quantitative portion of our equation. Need to be on the left and on the right. So just as a little bit of review, just kind of to reiterate, this part's important, just make sure you understand all of this. If you have carbon, for instance, 1C means 1 atom of carbon. 1O means 1 atom of oxygen. If you have O2, that means 1 molecule, but 2 atoms. If you have CO, that means 1 molecule of carbon monoxide, which contains 1 carbon and 1 oxygen. CO2 contains 1 carbon and 2 oxygens, but it's still 1 molecule. If you have 3 CO2s, you have to take the 3 to both of them, so that would be 3 carbons and 6 oxygens. And if you can count them up right here, 6 oxygens, 3 carbons. Okay? So these subscripts tell you how many atoms of a particular element are in the compound. The coefficient tells you about the quantity, or how many molecules, or how many of that compound you have. So, rule number one when balancing an equation: you can never ever change the subscript. If you change the subscript, you're not changing the number of that molecule, you're changing that chemical into a different molecule. And so you can never change the subscript. In order to balance, you can only ever change the coefficient, which is right here. Rule number two, that's what I just said. Change the coefficient to balance the equation. And practice will make you really good at this. Alright, so the equation we looked at previously. In order to get them to balance, if we place a 2 in front of hydrogen peroxide, which is H2O2, and a 2 in front of water, and leave oxygen as 1, then we can count up how many of each type of atom we have and see if it's balanced. So on the left-hand side, we have 4 oxygen atoms and 4 hydrogen atoms. On the right, we have 4 oxygen atoms and 4 hydrogen atoms. And so therefore they are balanced because we have the same number on both sides. So our seesaw, our teeter-totter, is going to be balanced. Okay, let's practice. So what I recommend doing is right along underneath the arrow, write down all the types of atoms you have. So in this case, we have both nitrogen and hydrogen. Then on both sides, write down how many of each one you have. So on the left-hand side, we have 2 nitrogen atoms and 2 hydrogen atoms. On the right-hand side, we have 1 nitrogen atom and 3 hydrogen atoms. So what I recommend doing is just start with whatever number makes sense to you. So whatever first pops into your mind, give it a go. So what pops into my mind first is my nitrogens are not balanced. So how do I make my nitrogens balanced? If I have 2 nitrogens on the left and I have 1 on the right, what if I just simply multiply by 2? So by putting the 2 in front of NH3, I change my nitrogens to 2, because now I have 2 nitrogens. But did that change something else as well? Yes. It also changed the number of hydrogens, because the 2 goes to both the nitrogens and the hydrogens. So how many hydrogens do I have now? 5? No. It's 2 times 3, which is your subscript, to yield 6. Okay? So now my nitrogens are balanced, but what about my hydrogens? What can I do to make them balance? If you place a 3 in front here, 3 times 2 gives me 6. I meant to write a 6 right there. So 3 times 2 gives me 6, which is how many I have. Okay, so now my nitrogens are balanced and my hydrogens are balanced. I'm done. You can put a 1 here. I think most of the homework systems make you put a 1. Technically, it's correct to leave it blank. So you can leave it blank or you can put a 1, but knowing your homework, they'll probably make you put a 1. Alright, so that's how you balance. We're just going to work for the rest of this PowerPoint some more examples. Really, practice makes perfect. The more you practice, the better you'll be at this. If you just simply Google balancing chemical equations, there are great worksheets online. And you can just have fun and just practice, practice, practice. Okay, so 1, 3, and 2. Oops. Alright, so let's do the exact same thing here. K, potassium, Cl, chlorine, and O, oxygen. On the left I have 1 potassium, 1 chlorine, and 3 oxygen. On the right I have 1 potassium, 1 chlorine, and 2 oxygen. Alright, so if I multiply my oxygen on the right hand side by 2, that's not going to quite do it because then I'll have 4. So let me start out on the left and try 2. So if I have 2, that's going to change everything on the left. It's going to make 2 potassiums, 2 chlorines, and 6 oxygens. Then on the right-hand side, I need to change this to a 2, which will make 2 potassiums and 2 chlorines. So now both of those are balanced. Then I can come over here to oxygen. How do I get 6 of them? Multiply by 3. So 3 times 2 gives me 6. Check my answers. Check, check, check. Okay. Next one. And I do recommend just stopping the video right now because I think you're getting the hang of it. And stop it, give it a try by yourself and then replay the video and see if you get the same thing I do. Alright, 1 sodium on the left, 1 chlorine on the left, 2 fluorines on the right, 1 sodium on the right, 1 fluorine on the right, and 2 chlorines on the right. So in order to get my chlorines to balance, I can multiply that by 2, which would change that to a 2 and that to a 2. In order to get my fluorines to balance, I need to make that 2, which would make my sodium 2 and my fluorine be 2. And now I'm entirely balanced. Let's see if the answer agrees with me. Good. Alright, next one. We've got a bunch more here to work with. Lead, oxygen, hydrogen, and chlorine. Okay, now this one's going to get a little more tricky because hydrogen is in both molecules on the left-hand side. And so whenever you change one, you have to realize that you're going to change the net total, but don't forget to add the other atoms. Additionally, make sure whenever you've got something outside of parentheses that you know it multiplies across. So in this case, there are 2 oxygens and 2 hydrogens in the lead hydroxide. Okay, so we have 1 lead, 2 oxygens, 3 hydrogens, 2 coming from here, 1 coming from here, and 1 chlorine. On the right, we have 2 hydrogens, 1 oxygen, 1 lead, and 2 chlorines. So we can really start anywhere. Our leads are balanced, our oxygens are not. Our chlorines are not as well. I might start with my chlorines just because it looks least complicated. So chlorine, 2 on the right, 1 on the left, so I need to multiply this side by 2, which changes both my hydrogen and my chlorine. So before I start adding up anything, I'm just going to cross off my old numbers. Then I've got 2 hydrogens from lead hydroxide and 2 hydrogens from hydrochloric acid. This gives me a total of 4 hydrogens. Chlorines, I now have 2. So now my chlorines are balanced, my hydrogens are not, my oxygens are not, and my lead is still balanced. So what can I do next? How about oxygen? In order to make oxygen balanced, I need to multiply water by 2, which would give me 2 oxygens over here, and a total of 4 hydrogens. Am I balanced now? Yes. Let's see if it agrees. Check. Okay, now we're going to get into our first set where we have polyatomics on both sides of the equation. What I find is helpful is if you see that you have a polyatomic that's the same on the left and on the right, instead of breaking it apart, you can keep it as a polyatomic in your work. So what I mean by that is we have aluminum, we have bromine, we have potassium, and we have sulfate. So we have 1 aluminum on the left, and once again, feel free to pause the video and come back to this. 3 bromines, 2 potassiums, and 1 sulfate group. On the right, we have 1 potassium, 1 bromine, 2 aluminum, and 3 sulfates. So I'm going to start with the most obvious. Sulfates need to balance. So I'm going to make there be 3 sulfates on the left, which would change my potassium and my sulfates. So now I have 6 potassiums and I have 3 sulfates. I can go anywhere from here. I will try my potassiums. So I need to have 6 potassiums. So that will change both my potassium and my bromine. So it makes it be 6 potassiums, but now I've got to change my bromines. So 6 bromines. Go back to the left now. I need to have twice as many bromines. So putting a 2 in front of that changes my aluminum and my bromine. Now I have 2 aluminums and 6 bromines. Am I balanced? Check. Check our answers? Check. Okay, let's look a little bit more at this equation. What does it mean? Okay, so if we have 6 moles of aluminum bromide, or it'd really be aluminum 3 bromide, how many moles of aluminum 3 sulfate are produced? So if we look at it this way, if we have 6 moles here, how many moles of aluminum sulfate are produced? So we could say it this way: if we have 2 moles, we produce 1. So if we have 6 moles, we should produce 3, right? Just kind of thinking about the ratios. Thinking about it logically like this, I'm hoping will set us up for our next lecture, which is where we're going to be thinking about what these coefficients literally mean. So meaning, what these are is this is showing you how many molecules can be converted into how many molecules, or how many moles can be converted into a number of moles. Meaning, if you have 2 moles of aluminum 3 bromide, you can create 6 moles of potassium bromide and 1 mole of aluminum 3 sulfate, as long as you have plenty of potassium sulfate to go around. Similarly, if you have 3 moles of potassium sulfate with extra aluminum 3 bromide, you can produce 6 moles of potassium bromide or 1 mole of aluminum 3 sulfate. You can also consider this as molecules. If you have 3 molecules of potassium sulfate and excess aluminum bromide, you can produce 6 molecules of potassium bromide and 1 molecule of aluminum 3 sulfate. And so just kind of thinking about these things will help you just kind of get ready for next lesson. But before we can begin the next lesson, we have to make sure we're really proficient at balancing equations. If you had 6 moles of potassium sulfate, how many moles of aluminum 3 sulfate are produced? So 3 moles produces 1, so 6 moles should produce 2. If you have 6 moles of potassium sulfate, how many moles of potassium bromide are produced? So 3 moles produces 6, so 6 moles would produce 12. And all that's looking at is the ratio of one to the other. So to recap, all reactions must have the same number of atoms on both sides of the equation to be considered balanced. So number and type is important. And let's hope our logic is better than some movies that we might have seen. And then last but not least, practice, practice, practice. If I can't emphasize this enough, those that are good at this have either practiced this type of logic before or practiced this very thing before. But everybody can get better at this if you just practice.